Sure. Okay. Hi. All right. So I think I'll start now. So we only have an hour, so I want to try and get as much done as possible. I'm hoping we can get through the questions. So let's see. All right. So this is the first question. Can everyone see this? You can just like let me know in the chat. Let me know if it's clear. All right, cool. All right, so Texas problem is optimal split. So Alice and Bob want to split the numbers 1, 2, 3 all the way to n optimally amongst themselves. A split is optimal when the total Alice gets x and the total Bob gets y as close as possible. So that means that the absolute difference between x and y is minimized. In each of the numbers from 1 to n must go to either Alice or Bob. The task is to find a way to distribute the numbers amongst themselves. The output the minimized value of the absolute value of x minus y. Like, does anybody understand what this problem is saying? Do you have an idea of like what to do here? I want to try and get like ideas from the audience today. Anyone? But does anyone have questions? You understand what the problem is? Like, you can ask me questions. Yeah. Yes, you can try. I'm not sure how to pronounce your first name, and I don't want to butcher it. So please.
Okay. Yeah, you can call me Arinze. Good morning.
Good morning.
Okay. Based on what I understand from the question, we have, let's say, an array of integers, right? We want to find a way to evenly divide that array, and the constraint we have is that the difference between each split should be, the smaller it is, the better our chance of solving it. Is that what the problem says? Or
Sorry, say it again. So you want to split the array into 2? Is that what you're saying?
yeah, between Alice and Bob, and the best, based on the constraint we have in the question, is our best, like the best possible outcome would be if the difference between both split is actually smaller than maybe
Right. So the values that Alice and Bob have should be as close together as possible. Is that what you mean?
Yes, but I'm not sure I entirely understand the question at all.
Okay, so you have numbers from 1 to n. right? So it could be 1 to 10, for example, right? And the question is saying, split 1 to 10 between Alice and Bob so that the total value Alice and Bob have are as close as possible. So let's look at an example and see what this means, right? So first example, you're given 3. So n is equal to 3 means that the array is 1, 2. So you have 1, 2, and 3 in the array, right? And the best way to split this, for example, would be to give Alice 1 and 2, and for Bob to take 3, or the other way around. And this way, the difference between the total Alice has and the total Bob has is 0, which is the most optimal solution. So 0 is like the best you can possibly get, right? Does this make sense? So if you have 5, for example, it means that you have 1, 2, 3, 4, and 5 in your array. You want to try and split 1, 2, 3, and 4, and 5 between 2 people, Alice and Bob, such that the total Alice has and the total Bob has, like the difference is as minimized as possible, like as small as possible. This means that the total that they have is as close to like as close to each other as possible. So one way we could split that is by giving Alice 1, 3, and 4, and by giving Bob 2 and 5, right? And then this way, Alice would have a total of 8, and Bob will have a total of 7. And the difference would be 1. Like, does that make sense?
Sort of. It makes sense a bit. Maybe it will become clearer once we eventually start solving it, I think.
Okay. Does anyone else have questions, have ideas for how to solve this? I'm going to just copy
Uh,
out some.
Hello, can I ask a question?
Sure.
What this is my first time attending the data structure study group. What language of choice would you be using? Would it be Java or?
I'm using Java, but
Oh,
that isn't like why? Why do you ask?
okay, no problem. Just wanted to be sure.
Yeah, Java, but um, like in my opinion, languages don't matter too much as long as you understand the problem and
Okay,
what the algorithm is. You can
okay.
apply it to most languages. All right, so I've set up like a thing to allow us to read the input, right? So we know that we have an input 5. So here I'm reading input 5 from um, the buffer, and I want to pass n to a method called find minimize value, and we just print that out. So this is just kind of an input. So does anyone have like any ideas for how to solve this? All right, cool. So let's take let's try.
Oh, sorry, Ayo, I want to actually like see if I could like try it.
Sure, yeah, let's go.
Okay. Since I think we're actually dealing with an array, right? And for like from the examples I've seen, I think they're like kind of sorted, right? So I'm thinking if we could like run through it, since it's probably going to be contiguous, like it runs from like one to like the end of the number, right? So we like use the way I will try to like attempt this is like using this pattern I call like sliding window of sorts, where we like have where we start, right, and wherever we get to, and yeah and we have another variable that like stores the sum of all the numbers we have like gotten to like compare to the rest, so we get to like compare both sides.
I'm not sure I understand. So sliding window, I know
Okay.
sliding window. Sliding window, you have 2 pointers. Pointers are moving.
Yeah, right.
Okay, so how do you want to apply that here?
So since we're like sharing it between like two like parties, right? So we tend to like probably we start at one. Let's say our window like starts at array of 0, which is currently 1, right? And here we have another variable that like stores the sum, where have like probably windows or sum where it keeps like going. So if you like keep incrementing, right? Maybe we are on like on the second what's it called, on the second index, it gets to like that's going to be 2 plus 1, right? It stores that. If you get to like 3 as well, it stores that as well. So it stores 3 plus 2 plus 1. Then we compare like then we remove like the total number from the like variable we are stored, and we compare the like the max dot maximum to see if we can get something better, like a difference that is lesser than what we have.
Mm. Okay. No, I'm not sure I actually understand. So can you say that again, but very simple, like simpler than what you did before?
Okay. Like we start like having a variable, right? Let's say Windows starts.
Okay,
We have that
so
variable.
I have start. Okay, 1 second. I'm going to follow you. Let's see what you're saying. All right, I have a start variable. A start store.
Yeah, that. So it stores the first index. That's like array of 0. It starts there.
All right, so here you're assuming that I have an array that goes from 1, 2, 3 all the way to n, right?
The first element in the array. That's array of 0.
That's so
Like the contiguous is some.
sum. Okay, sum will be 0.
So when we're like looping through the array,
Okay.
so we like keep adding like the
Right. So this is 15. You're saying
yeah,
I'll
like
add everything in the array and get 15. Okay. So when I get 15, what do I use 15 for?
that. Okay, I'm thinking like actually not like know how to like solve everything, but I'm just thinking through my head that, okay, if like we keep removing our sum there and we keep comparing with these marks, then we get the lowest differences
I
the lowest
see.
difference rather. I don't know if you
Okay, I
get me
see.
now.
So you're saying that we would, yeah, I see what you're saying. So you're saying that we add all of the values in the array and
Right.
we try to now go through the array one after the other. And as we go to the array, we add the value at the current index to another sum variable, a sum variable that we have. And as we keep adding values to the sum variable, we check if. So this is where I kind of miss it. So if I keep adding values to some variable and I have my total, what do I do next? So for example, let's say that I've added sum plus 1. So what you're saying is that I'm going to this array, right? So I'll start from 0, add 1, add 2, add 3. So where do I stop?
Like what I have in my head currently is probably when we have this 15, right? And we like remove or like this marks is going to be comparing our current like marks, which is 0, right? And the solution we get in the what would I call it now, like this summary minus the
Yeah.
current sum we have, right? Then we are going to like look for the minimum here, not
All
max
right, so
actually.
let's do this. So if I have some array, that's 15. If I'm adding 1, 2, and 3, it means I need to subtract 1, 2, and 3
Yeah,
from this, right? Okay. So what do I do after
yes.
this?
Then we compare it.
This will give me 9. This will give me 6. Okay.
Okay. Then we compare. Sorry, what's that? The second this thing we have.
What
This
second thing?
zero. I can't, okay, this sum. Sorry, which what are we like adding together there? I'm a little bit confused.
What's
Zero, one, two. This like the
some
one before the
starts
mark.
some starts from 0, right? So one,
Yes.
you're the one that said one is like first index is 1. So that's what this one
Right.
is. Second index is 2. That's what this 2 is. Third index is 3. That's what this 3 is.
Right. So, like what I'm saying now, like okay, let us now we have like simulated that we are like on the second index, right? That's the way. So I'm saying we would subtract 15, the total sum of the array minus the sum of the current index we are on. Then we like tend to like compare it with our marks to see if we are going to get anything lesser than our current difference.
Okay, so you're introducing a few values, right? You're talking about difference, you're talking about max and so on as like yeah, diff and max at least. I don't understand how diff and max come in here, right? Like
Okay, I guess
where do you get diff from? Are you saying the difference between, because now everything I'm adding to sum, I'm subtracting from the total sum of the array. So you said we should add 1, 2, and 3. So I'm subtracting 1, 2, and 3 from the sum array, right? Like this is what you mean. So when you say like
ye-
when you say maximum is 0, I'm not sure what you mean. Like where does maximum come from?
like like the way I have it in my edge, right, is to like store something, like to like store because our what's it called? Our variable is going to like be storing that max the max comparison, right? So we are going to be comparing between what we like what we have at the moment and the max we want to store inside of it. I don't know if I could like probably write out my thought process in the chat. Actually, now have you all together in mind. I was just thinking through as well. Perhaps might
Okay,
like
so
stop here
let
and
me know.
think.
Let me know if you. Yeah, that's fine. So I want you to think about it a bit. Like I want you to, come back and like let me know when you're done thinking through, because I actually want to see this through. But yeah, I want to know if anyone else has a suggestion. Do we have a link to the question? Um, I
Yeah,
think it was posted
yeah.
on the chat,
I have
but
a suggestion.
sure.
Okay. It's just in my head, like so. It's just something to have in mind. So I believe
Sure.
if the array is sorted, right, and we need two arrays with the closest with we need two arrays whose sum is as close as possible.
Mhm.
We can take every other element of the index. So, for example, array one will be every other element in the index starting from the very first member of the array.
Right. So I don't think that would work because let's assume we have 1, 2, 3. I think I understand what you mean.
Yeah,
So you're saying array 1 would be 1 and 3, and array 2 would be just 2, right?
yeah, sure.
Yeah, but the actual best way to split this would be 1, 2, and 3.
Okay. Yes, yes, yes. Okay.
All right. So cool. So these are like all good ideas. Like it's kind of useful to think through the problems, try out things for yourself, test ideas, which is why like I'm asking people to contribute. The solution for this is actually pretty straightforward. So this week we try to focus on, like for this hackathon, we try to focus on greedy approaches, like greedy techniques. Greedy is just means that it's like techniques where like you try and pick the best path possible at each step, right? And it can mean different things, right? It's like there's no one way to solve a greedy problem. But let's look at this, right? Let's assume we have this. Let me use an actual example. Do we have 5? Okay, we do have 5. So this is an actual example. So let's not look at the solution, but let's try and solve this ourselves. So we have Alice and Bob that we want to split these numbers between, right? And we say that whatever sum Alice gets, we want to minimize. Like once you start seeing anything like minimize something, like that what is probably tending towards greedy. So we want to minimize the sum of what Alice gets and the sum of what Bob gets as much as possible, right? So their values should be as close together as they can be. So the last person that spoke, I think she was just said something that was important, which is the array is sorted by default. So we can see from the example that it starts from 1 and ends at n. So by default, it is sorted. And so the first thing that we could do here, we know that the values at the last indexes would be the largest values in the array. So we can give those values to Alice and Bob because we know that the largest possible, right? So what this means is Alice could take 5 and Bob could take 4 to start. So this goes away. So we have 1, 2, 3 to share. Like this way, we have given them the greatest values possible that they could have. And then what we do next is we now keep going from like the back, where we say, okay, so if we add 3, if Alice is greater than Bob, then give 3 to Bob. So this way we have 4 plus 3 because Alice is greater than Bob. So here we have 7, right? And so 3 is gone. We have 2. Now Bob is greater than Alice, so we add 2 to 5, right? And we get 7. And we remove 2. And now they're both the same, so you can add the 1 to any of them, which would, you can add it to Alice and this will give us 8. And so this is the best place we could possibly have, which would be a difference of 2. And so the trick there was initially giving the largest 2 values. So we know that the array is sorted. We want to minimize the total that both of them have. So the first thing we do is just give them both the largest values we can possibly get. And at each point, so the greedy technique here is at each step, what we're just doing is checking like which person should we give this value to? And how do we know that? Just by comparing who is greater than the other person. And then we just give that person the value. Yeah, so does that make sense? Like, does this like make sense to people? Do people have any questions? Anyone? Okay, I guess not. So, so this would be
Makes
pretty
sense.
straightforward. Cool, thanks. So this would be pretty straightforward, like to write in code. So I would just, we don't have a lot of time, so I'm just going to go ahead and write. So we would have like someone called, like a variable called Alice. Alice would get the n. So let's say that we have n here, right? N is 5. So this, I'm trying to write an optimized version of what the solution might be, right? So instead of creating an array that's like, I can get n and then create an array that has 1 to n, and then start doing, start going back the way I was going back here, right? So I can, from n, I know n is 5, so I can create an array like this, and then do exactly what I did here. Or I just know that the largest variable I have is 5, and I'm going from 5 to 1. So I can give Alice n. So I give Alice 5, which is the largest I possibly have, and I can give Bob. When I give Alice 5, I subtract 1 from n. This would make n 4. So I'll give Bob n now, and this means I'm giving Bob 4. The same thing I was doing here, right? So I'll give Alice 5, then I give Bob 4, which are the 2 largest values. Instead of creating another array, I can just use the existing variable, right? So I give Alice n, then I subtract 1 from n. I have 4, so I give Bob 4. I just subtract 1 from n. So that means I'm at 3 at the moment, right? And then what we said is while n is greater than 0, we want to check if Alice is greater than Bob, then it means that we want to give Bob n, right? Else, we want to give Alice n. And every time we give someone n, we need to subtract n. We need to subtract 1 from n, right? And then at the end of the day, we just want to do like an absolute difference of Alice and Bob. All right. Does anyone know why I'm doing the absolute difference? And does this make sense to people? Like, does this code make sense to people?
I think the absolute difference is like remove the sign.
Right. Okay. Yep. Exactly. So yeah, this looks like it might work, but giving Alice the greatest value, then giving Bob the second greatest value, then we keep checking while n is greater than 0. If Alice is greater than Bob, give Bob. If else, give Alice. And then we keep subtracting one at each point. And then for the results, we get the absolute difference and return that. So let's see if this works. IO exception. Okay. I think I should use scanner instead of these buffered reader big. I was given weird errors. Cool. So this is the expected submit. All right, cool. Looks like that worked. So let's quickly go to the second problem, which is min notes. All right. So let's read this. Can you assist Wilson in paying with the fewest notes possible after he just made a purchase at a store? Wilson bought. So again, we're seeing, paying with the fewest notes possible. We're trying to minimize something. And so once you start seeing like language like that, you know that this is leaning towards greedy, right? All right. So Wilson bought items worth $10 in total, and Wilson has an infinite amount of dollar notes with values in the range 1 to 9. What is the minimum amount of notes Wilson has to pay for the items? Wilson has to pay exactly $10. So what does this mean? So we have 18. So Wilson has to pay $18. And to pay $18, Wilson only needs 2 notes because he can pay $9 twice. So we know he only has notes between 1 and 9. And so to pay 18, he just needs to use 9 twice. Do we have another example? Yes, we do. So Wilson wants to pay 2. He only needs to use 1 note because he has $2 straight away. Wilson wants to pay 17. To pay 17, he can use one $9 note and one $8 note. So he has to use 2 notes. So yeah, does anyone understand this problem? Want to like give ideas here? Yeah, kind of similar to the first one, if you ask me. Anyone? No one. Okay. So I'll try move quickly. So let me first of all take again. I have my thing that needs to read input here. Give me one sec. So I need to read n is the amount that Wilson needs to pay, right? And I have a method called min count. So min note count. So I basically want to return the smallest number of notes that Wilson needs to be able to pay the total amount, right? So private static int this. So this is the total amount that Wilson needs to pay, right? Okay. So does anyone have ideas here? Like this is kind of straightforward. So let's use the first example, 18, right? 18, we know that 18, you can get 9 twice. Like 9 plus 9 gives you 18. So Wilson only needs 2 notes, right? For this one. For 17, we can have 1 9 and 1 8. That gives you 17. That's also 2 notes. I mean, let's think of another like strange example. Let's say we have 130, right? Does anyone have any ideas how we do pay 130?
I think we'll have to do some kind of modulus with 9 anytime the amount to be paid is more than 9.
Okay, why do you say that?
Because we know that 9 is like a cap, so to speak. 9 is the cap on the value of each note that Wilson has.
9
So
is the
if
cap on the value of each note. Okay.
yes, so because we are going from $0 to $9 notes, right? So we know 9
What?
is the cap on the value of each individual note. So we have to figure out if it's more than 9, then we know we have to do a modulus of 9. Like how many nines can we get out of 130?
No, but
So
modulus of 9 doesn't give you how many 9s you can get out of 130.
what will be left rather? Okay, so yeah, so we'll need to know both the quotient and the modulus. So that will be the number of 9s in 130. The number
Okay,
of
so
9s in
130 divided by 9 will give us something, right?
will give us something, yes. So
Okay,
whatever is left will most likely be less than 9. So it will be the number of 9s in 130, then plus one note.
right. Yep, that makes sense to me. So what he's saying is that 9 is the largest value. We want to return the minimum number of notes that Wilson can pay. And what this immediately means to me is that, I mean, they told you that Wilson has an infinite amount of dollar notes, right? So the amount of 9 that Wilson has is not capped by anything. So Wilson has infinite 9s. And you want to if you want to minimize the number of notes Wilson would pay, then it makes sense to use the largest notes Wilson has as you can. And so what this means is that as much as possible, we want to use as many 9s as we can, but we need to pay exactly the amount. So we wouldn't always be able to use only 9s. So for example, in this case, 130 divided by 9 will give us something like 14. 14 times 9 is something like, give me a sec, 120 something.
126, then remainder 4.
Right, 126. Right. And so 9 can only go up to 126. But we need to pay exactly 130. And so we can take the one, like the remainder is 4, and 4 is less than 9. And we have 4 in the array.
List of notes.
Right. And so what Wilson would have to pay here is he would have to pay 14 9s and 1 4. Maybe use words here. 14 9s and 1 4. Right. And so Wilson would need to pay 5 notes here.
15.
Sorry, 15. Thank you. 15 notes. This makes sense to people.
Yes, it does.
All right, so this one is like pretty straightforward, I think. So total amount is something like, or total 9s maybe. Right, so we call it total 9s. It's we say like total amount divided by 9, right? That will give us the first thing. And then we also want to get the remainder if it exists. That would be something like total amount modulus 9. Right. And yeah, all we want to do is return. Okay, so we need to do like a check here, right? If remainder is equal to 0, we want to just return total 9s. It means there's nothing to add. So just return the number of 9s that we got here. Else, we want to add 1 to the total 9s because we know that we will need to pay at least one more currency if remainder is not 0. We don't actually care what the remainder is, to be honest. We just care that there is a remainder. If there's a remainder, it means we need 1 extra note. If there's no remainder, it means that total, like the number of 9s is fine. Does this make sense?
Yeah. So I think an edge case might be
Yeah.
when the amount to be paid is less than 9. So that would just be one note. We just return 1.
That's good. Thank you. That's perfect edge case.
I have a question. Like I didn't really study like the
Okay,
question was it really clear that it must be consecutive, the list of nodes. So I'm thinking of a case where the remainder will be like 8 and we don't have 8 in our list of nodes. Right?
Okay, I'll come back to each of you in 1 sec. So
Okay,
the
sure.
edge case that the edge case that the person mentioned just now, if it's less than 9, it would it still work here? So let's say that we had, if we have something less than 9, right? Like, let's say 8. 8 divided by 9 would give us something like 0, I think. Or like anything less than 9 would give us, like an integer, if we use an int, anything less divided by 9 would give us 0. And then remainder, total amount modulus 9 will give us that value, right? So for example, if we had 8, let's say our total amount was 8. So 8 divided by 9 will give us something like 0 point something something. But that doesn't matter with integer. Like all of the points will just get scrapped. And then if we do 8 modulus 9, I think we get 8. And so here, the total 9s will be 0. And as long as we have a remainder, we would return 1. So it would be 0 plus 1. So I think the edge case is also covered.
Oh, right. Sorry, I think I was stuck in JavaScript thinking.
Right. But yeah, that's a good edge case to think about, to be honest. Like if you're in an interview, this is something you want to say. Like let them know you're thinking about that. Okay. Chibuzo, sorry, what were you saying? Can you say that again?
Yeah, I was just wondering if there could be a case where the remainder, like for example, in this case, 8 won't be amongst the list of nodes also.
No. So we know that it would always go from 1 to 9. So he always has, so Wilson has notes in the range of 1 to 9. So 8 would be there for sure.
And it's consecutive, okay.
Yeah. Yeah. Cool. So this should work. Let's see. I think I need to throw this. There's something to throw, right? Throw. Okay. I keep forgetting.
Yeah, hello?
Yeah. Someone has a question.
Yeah, I just wanted to point out something concerning what the other guy said as regarding the worst case scenario. I mean, where mentioned if the number is less than 9, the total number is less than 9.
Yeah.
So I think that if that if is actually at the top, because I really don't think it's really necessary we finding the total 9s and the remainder. Since we can actually just put an if condition and just check first of all if the total amount is less than 9.
Yeah,
I don't know if you get what I'm saying.
You're saying that we should add an explicit condition at the top to check if the total is less than 9. So if it's less than 9, return 1, right? That's what you're saying.
Yes.
I mean, yeah, we can do that for sure, and that's like that's an added layer that would be useful. But we still need to divide the total amount by 9 anyway, because we need to get the total number of 9s we can get out of the total amount. Like, do you understand why we need to do this?
Yes, but what I'm saying is that in that case where we already know that the total number is less than 9, there is there's no any need for us now going through the total getting the total 9s, getting the remainder.
I mean, yeah, agreed. Like you can reduce computation. I mean, it doesn't really matter in the grand. It doesn't really matter in the grand scheme of things. But I think that, like, for this particular example, because this is just one case. But yeah, when you're like building systems and stuff, having like explicit conditions where you like exit the code as quickly as possible is useful. So yeah, like I agree with you. Like add the like bad conditions as early as possible and be explicit so that you don't have to compute. So yeah, that's fine. Like that's okay. Anyone have any other questions? All right, cool. So let's see the next one. Study group meeting. So Adora has organized a meeting for members for her study group in her city. And she wants to select the best place for the meeting. Adora's city can be represented as a 2D grid, and each person on the 2D grid lives at some coordinate XY. Let me try and zoom in here. Adora knows the location of the n people she wants to invite. The locations can be denoted using the integers x1, y1, x2, and so on and so forth, up to xn, yn. Given the locations of n people she wants to invite, your task is to find some meeting points x, m, y, m that minimizes the total Manhattan distance each person has to travel to the meeting point. Mathematically, you should minimize total distance as is equal to summation of 1 to n. So I is 1, so you're starting from x1 to x. Summation of 1 to n is what I'm seeing here, okay. So x minus greatest value of x plus y minus greatest value of y, blah, 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 where x denotes absolute value of x, okay. I'll use the minimized value of the minimized total distance as the answer to the problem. Okay, I see. So total distance that everybody has to travel is the total distance that everyone that Adora is inviting would need to travel, right? Okay, so that makes sense. So when you find the meeting point, x, m, y, m, what this is now saying is that you should find total distance that everyone has to travel. So what is the distance that the first person has to travel, plus what is the distance that second person has to travel, plus what is the distance that third person has to travel, and so on and so forth until you get to the last person. And then you return that total distance. The idea is that you want to minimize the distance each person has to travel. And so what we actually we care about minimizing as much as possible is the distance that we decide for the meeting points, like the location for the meeting point, right? So how do we decide the location for the meeting point? I think that is what this question is asking. So let's see. To output the total distances each person covers to choose a meeting point, not the meeting point. Right. Okay, that makes sense. We have some constraints here. I don't know if they're too important, but let's see. The total number of people that Adora can invite is, I think, 10,000 or 100,000. I think it's 100,000. And the greatest X can be 1 billion. Greatest Y can also be 1 billion. Total number of people can be up to 1,000. Sorry, 100,000. Output the sum of distances traveled by each person to reach the meeting place. So let's say we have this example, right? So we know there are 2 people that want to travel. These are the location for the 2 people. Let's go through this. So Adora is inviting 2 people. Their coordinates are 1, 2, and 1, 4. The optimal meeting point is 1, 2. And the distance that the first person has to travel to the meeting point using the formula that we gave is 0. And the distance second person has to travel is 2. So the total distance that both of them need to travel is 2, which is optimal. Now it is possible, important to note that there can be more than one valid meeting point, like more than one meeting point that minimizes the total distance, right? So if the optimal meeting point we decided was 1, 3, we would also still get a total distance of 2. If the optimal distance we decided on was 1, 4, we would also get a distance of 2. So yeah, there might be more than one valid meeting point. And basically we use the same example, right? So there are 3 people she wants to invite. These are their 3 coordinates. Decide that 1 point is the valid meeting point, and the total distance that everyone, like when we calculate the total distance everyone has to travel to the meeting point we decided on, it is 4. And so I think the crux of this problem is finding how do we find an optimal meeting point, right? So that is like the main crux of this problem. Does anyone have ideas here? Questions, ideas, be anything.
Sorry, can you scroll to the first input again?
Sure. I don't have questions. How do you decipher the formula? What formula is that? Please, if you have questions, just like speak. Because yeah, like you can speak. if you want.
Okay. Hello, can you hear me?
Yeah.
Yeah, at the problem statement where it said mathematically you should minimize total distance using total distance equal this, so you can get the absolute value of x. How do you like break
No,
it
no.
down on there?
So you minimize total distance.
Mhm.
Minimizing total distance. So the way you calculate total distance is this formula.
Okay.
But you want to minimize the total distance you're getting. So the formula, like you're not minimizing total distance using this formula. You're
Okay.
minimizing total distance, and the way you get total distance by calculating is by using this formula. The way you minimize total distance is by minimizing, like getting the optimal meeting point. Because
Mhm.
what total distance is calculating is what is the distance that the first person takes to the meeting point plus
Okay.
the distance the second person takes to the meeting point plus third person up to the last person, right? And that will be total distance. The way to minimize
Mhm.
the total distance you're getting when you sum like the distance everyone is traveling is by
Mhm.
minimizing or getting the optimal point that everyone is traveling to, right? So if you get the location that is optimal, as in like you're minimizing the distance everyone has to travel to, then total distance you calculate for everyone's distance will be minimized by default. Does that
Yeah,
make
okay.
sense?
Yeah, that makes perfect sense. Yeah, thank you.
All right,
All right, sorry, I have a question. Is the
sure.
total distance given?
Total distance, this is how you calculate total distance. You calculate total distance using this formula.
Oh,
And again,
sorry,
like I
I mean,
said,
is the meeting points given?
no, that's the crux of the problem, right? So you need to find, everyone's location. You want to find the optimal meeting point. Okay, so sorry, yeah, ask your question.
Not exactly a question. I was just thinking that wouldn't be this be some kind of a numerical optimization thing,
What do you mean?
like because so what we are trying to look for, right, is to arrive at the meeting point where we're comparing each person's distance from it would be the least. So wouldn't isn't it like an approach of where we have to like keep trying different possible meeting points and then
I
getting the
mean,
one that
we can
okay.
try different meeting points for sure, but like, how do you know the meeting points to try?
Yeah, right. Yeah, I think that's why I said this numerical, like those things where you pick somewhere to start from and then you start going lower or higher depending on how close you are to an optimum. But I'm not. It feels too. Maybe this is overthinking it.
Yeah, that could be one way. Maybe we could get to the answer with that, but I'm not sure at the moment. Um, I'm not sure. Does anyone else have any ideas?
Hello.
Yeah.
Yeah, so the idea I have is what if we add x1, x2, x3 up to xn
Yeah.
divided by the total number of people that are invited? Then we have
Okay.
y1, y2, y3 to yn added together divided by the total number of people that are invited. I feel that should be the value of the x and value of the y based on those operations should be the optimal meeting points.
Yeah. Okay. I like that. That sounds interesting, right? So you're saying that we should get an average of the x's, right? And get average of y's.
Yeah.
And your value would be what's average of x and average of y. That'll be the
Yeah.
distance.
Yes.
Okay. I mean, that's interesting. I don't know if that would work, but it sounds plausible and we can test it, right? Let's see. So we have 1, 2, 1, 4. I'm happy to actually try that out and see if it works. I had another idea, but we can try this one first, to be honest. 1, 2, 1, 4, right? All right, cool. So if we add all the x's, we get 1 plus 1. 1 plus 1 divided by 2 is 1 plus 1 is 2. 2 divided by 2 is 1. So average of x is 1. Then we have 1 plus 4. Sorry, no, 2 plus 4. This is average x. And this is average y. All right, 2 plus 4 is what, 6. 6 divided by 2 is 3. Yeah, and 1, 3 is like a valid location, I believe. Yep. So let's try with this one. 3, 3, 3, 3, 2. Let's go. So we have 3, 4, 3, 4, 2, 1. So we can have average of x as what exactly? 3 plus 3 plus 2. That's like 8 divided by 3. 8 divided by 3 is what? 2. 8 divided by 3 has to be 2. It can't be 3 because that's 9. So that's 2 integer. So average of y would be what? 4 plus 4 plus 1. This is what? 8, 9. 9 divided by, okay, this is cool. So this is 2, 3. So the location we get here is 2 and 3. Is 2 and 3 minimized? Let's see. So what did we use? We used 3 and 4 as the Manhattan location. That gives it, so the total we get here is 4. Let's see what 2, 3 gives us. Right, so if person at 3 and 4 travels to 2, 3, what is the distance they travel? So they would travel something like, how do we get the distance again? We get distance by doing absolute value of x, the location of the person and the location of the meeting point, plus absolute value of the y location of the person minus the y location of the meeting point, right? So what this means is for distance that the first person traveled, so distance 1, we would have 3. So this is the first location, which is 3, 4. So 3 minus what? Minus 2. Absolute
2
value of that.
plus.
Sorry? Hello, do you want to say something?
No, not at all.
Okay. So absolute value 3, 2 gives what? So 3 minus 2 is 1. Absolute value of 1 is 1. 4 minus 3 is 1. Absolute value of 1 is 1. So this is 2. All right. So we have distance 2, which is also the same thing. Same location. This is also the 1, 2, Abi. Am I getting that right? Yep. Then what's the distance of the last person? So distance 3 would be 2, 1. We have 2 minus 2 plus 1 minus 3, right? 1 minus 3. And that gives us what? 2 minus 2 is 0, so that's fine. 1 minus 3 is minus 2, I think. And minus 2 absolute value is 2. So this also gives us 2. So the distance, total distance we get here is going to be 2 plus 2 plus 2, right? So 2 plus 2 plus 2. This gives us 6. And we have a value, we have one coordinate that gives us 4. So I don't think the average will work. It looks like it works in some cases, but it doesn't look like it works in all cases. Yeah. What did you want to say?
I think I imagine that it might be, if we would go the optimization route, it might be a good way to choose a starting point. This average method.
Sorry, say this again. It might be a good idea to choose the starting point as
the average of everybody's distances. What we are computing here as a starting distance, then test if it's an optimal distance, and then if it's not, try maybe something higher or lower.
So how do I test if a distance is optimal, and how do I pick my first distance?
Yes, I don't have the answer for the first question you asked, like how do I test if it's optimal, because that means we need to have something to test it against. But what I'm saying is that a starting point could be this thing that was suggested here, like finding
Okay,
the
like the average. I
Yes.
see. So the average can be the first, can be a point we can start from. Okay, that sounds good. That sounds possible. Someone wants to ask a question. Ayomide Oyekanmi, please ask. Hi, please ask your question. All right, cool. Whenever you're ready, please just unmute and ask. In the meantime, I want to explain something. So let's assume, right, that we have. Let's take these three guys up here. You know, and we have this. So we have these guys. Let's imagine that we don't have any. That we don't care about the y for a second, right? So we only care about x. So this would mean like our first point is 3, 0. Our second point is 3, 0 as well. And our final point is 2, 1. Right, sorry, 2, 0. How do we plot this on this graph, right? So we would have something like, I don't know, maybe 2 here, and then 3 here. That's too far for 3, maybe 3 here, right? So we want to go from, we want to find, there are 2 people here. I don't know, there are 2 dots. I don't know how to mark 2 dots, but let's just imagine 2 dots, LOL. And then there's 1 dot here. We want to find, okay, actually, maybe something simpler that could help understand this is, let's forget this. Let's imagine that someone was at 4 and someone was at 5, right? So, sorry, 2, 3, and 4. 2, 3, and 4. All right, but this could be 3, and then we would have like a 4 here or something, right? So what do you guys think would be, like, let's say we had this location, what do you guys think would be yeah, we're only using Java, but I keep asking, like, why is this important? Like, do people want to see something in specific language? Is there something that, you know, is concerning about Java? Like, people keep asking if we're using Java, but again, I say, like, the language is not too important because nothing we're doing is language specific. Nothing we've done so far is language specific, right? So whatever we do, you can replicate it in any language. But if there's something about Java you don't understand, you know, ask me please, and I would explain. Most of the like on parts that are the most confusing are buffered reader, buffered writer, blah blah blah. All of that is just Java's way of reading input and writing output, right? So it's not very important for you to understand that. What's important is are the methods we write to solve the problem, and those are language agnostic as far as I'm concerned. Right, cool. So what is does anyone have any idea for what if I had people at these locations, right, what would be the optimal distance to meet or the optimal location to meet?
should be 3.
3. Why do you say 3?
Because it just intuitively feels like everyone has to travel the least distance to get there. Someone has to go 0, and the other 2 people have to go 1. Every other distance would take every other person longer.
Okay. If I had an extra, let's say I had an extra person here, what would now be the distance that I can travel? The minimum distance travel.
That would be 1.5 in between 3 and 4.
Here. So that would be, no, sorry, in between 3 and 4. Yeah.
3.5.
This would be minimum distance travel. Okay. So I'm trying to like play with an idea for how we peak. So versus using average, is it possible to just arrange X's and Y's on a line and pick the optimal solution by doing that. So let's see. If we had 3.5, yeah, that looks optimal. But what do we do when we have trying to like if anyone has ideas here, like please let me know. I'm thinking about what to do here. Just give me a sec.
If we theoretically shift the two away from, if one of them is not on the x-axis, I'm trying to wonder what the effect would be.
Okay, what do you mean?
Like when we, if you know, this is like kind of obvious because everyone is on the same axis, is on the x-axis, right?
Yeah.
So, you know, the shortest distance will be the midpoint. But let's say 2 is not on the x-axis. Let's say 2 is not on point 0, 2, is on say point maybe 2, 2. How would that change what the minimum distance should be, and could be like build a formula out of that to see the effect of a different axis?
Okay, so if you had 2 here, you're saying that this person is here.
Yes. So
okay.
It doesn't seem obvious to me. I'm just grasping at straws.
No, yeah, I mean that sounds good. So what this means is that this person is at what this means is that this person is at here and reaches here. So they meet somewhere here. Okay. So what does this mean to people?
It doesn't seem obvious at all.
Remember that there are many ways to get the minimum point as well. Like there are many. There can be more than one valid point.
Okay.
So we need to find a midpoint in some way, right? At each point, we're picking like a midpoint. This 3.51, I'm not very sure what we're going to do with it yet, but let's just hold on to that for a second. If I had an extra value here, like 6, right? This automatically means I'm picking 4, right? Because, yeah, like this automatically means I'm picking 4 on the x-axis. And so like what I'm theorizing is that we have the x and y values, we bring out the x values and arrange them in a way that, I don't know, like in a sorted way, and then pick the midpoint. And for the y-axis, we do the same thing, right? So for y, I have 4, 4, 1. I mean, yeah, sorry, we've kind of stopped using this example since. But the same thing we'll do for the x-axis, where like at each point we seem to be picking like the midpoint between all of the points. We can do that for both the x and the y-axis. But my idea does not involve like, using a so for example, if we did let's give me one sec. So if we did mid of, let's say we had this in an array, right? Give me one sec. So we had 2, 3, 4, 5, 6 in an array. To get midpoint of this, what would we do? We would just do there's this thing where you can do int mid. I don't know if it's big, but give me one sec. One thing we could do would be to do like first index plus last index divided by 2. I think the fastest way would be, another way would be to do int mid is equal to low plus something like high minus low divided by 2, something like that. And the reason why we do this is because of some issue where like it's possible for us to go out to overflow the integer if we just do first plus last divided by 2 all the time. But first plus last divided by 2 usually works for most cases, and I think it will work for our case anyway. But this is an optimized mid formula, like for people that are interested in that. So if we do first plus last divided by 2, right, this would be first index is 0, last index is 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 4. Right, 4 divided by 2 is going to give me 2. And so 0, 1, 2 means that I pick 4 right here. And 4 would be like my optimized distance, right? If I had just 2, 3, if I had 4 values, right? In this case, our solution was 3.5, but the idea I was thinking about doesn't actually apply. And I'm actually intrigued to know how that's, whether like 3.5 is what we should actually use or not. I don't know. But what this would mean is, what instead of doing, so we'll do 0 plus 3. 0 plus 3 is 0, 1, 2, 3 divided by 2. And 0 plus 3 divided by 2 is 1 in integer, right? If we cast it to int. And 1 is 3. So that's 1, we're picking 3. Right, someone says that the value needs to be an integer. Doesn't seem like 3.5 would work. Why do you say so? Yes, it does say it in the question. Integer meeting point. Yeah. See, I even missed that. Thank you for helping there. So 3.5 would not work because it is decimal, and the question specifies that we need an integer meeting point. And so one thing I was thinking about was, instead of trying to find averages, we can just arrange our x values in an array like this and pick the middle x. We can arrange our y points in an array in like a sorted form and pick the middle y, and that would be our solution, right? So this means that we're picking the mid x and mid y when we sort it, and that location will be our solution, right? So in this case, if we have something like 3, 3, 4, 3, 3, and 2, so we have 2, 2, 3, 3. This is for this. I shouldn't scatter this one sec, sorry. All right, cool. Let me just copy this out. All right, so let's say we have this, right? So what that would mean would be, for x, it would have something like 3. So sorting it, so it starts from 2, because 2 is the smallest x. And then we'd have 3 and 3, right? And then we would have 1, 4, and 4, right? And then if we pick the mid, I mean, we calculate this, we're going to get 3 and 4 as our midpoints, right? So we'd have something like 3 and 4. And I think 3 and 4 was like the location that the example chose. So that was one way I thought about solving that. But let me see if it applies to the other thing as well. This one is just, they're just 2 points. So it doesn't really help. The one that would have helped would be if there were more, like an example with like a lot more points. But this is one thing I want to try out though. Like, I think that if you have a group of people, you have all of their locations, one way to optimize the meeting points would be to, like, no matter the dimension this is, right, whether it's 2D, 3D, 4D, whatever, one way that like all of them can meet at, that is optimized, is you take each dimension, find the middle points, and make that into a point. So in this case, if you're finding the middle point of x, finding the middle point of y, and making midpoint of x and y into one location, and that will be optimized. At least that would be an optimized point. If this was going up to 3 as well, you add the midpoint of Z and still do the same thing, and that would be an optimized place. So I think this would work where you take
Yeah. What of if like this the number of like places the people that are supposed to attend adorance meeting they are like 4. That means you have to add the two add 2 values and divide by 2, and it might give you like a decimal, yeah, to get the midpoint.
Yeah, so in this case, right, I'm not thinking about the mid in terms of like the values themselves, where it's like, okay, so let's work with what you're saying, right? So let's say we have 2, 3, 4, 2, 3, 4, 5. What you're saying is because we have 4 values, you're saying we should take the 3 plus the 2 middle values and add them and divide by 2. That's what you're saying, right?
Yes.
So that's interesting.
No, I'm not like I'm just following your what you are saying, that if you put it in a sorted form and then get the middle. So I was like, if it's that way, there are like 4 values, like to get the midpoint, this is how you get it, but that's not what you are thinking, right?
Right. So one thing, this is interesting, and I actually don't know why we do this, but when we calculate mid, right, I gave 2 formulas so when we're writing code, usually this is how we calculate mid for most like things I've seen anyway. And this is not to say that it's right in any way. Sorry, one sec. Why am I doing this? Right. So there are 2 formulas for mid, which is first plus last divided by 2, which you can see there. And there's another one where you can do like last, what's it again? Last plus first, no, sorry. First plus last minus first divided by 2. There is like there are blog posts that explain why this is a formula that we use. This is kind of better than this one because this one doesn't allow integer overflows. But I can't remember off the top of my head exactly how to explain that right now. But these are the formulas for calculating mid. So what you're saying sounds correct to me, in that I want to find the middle of 4 values. What I would do is to take the 2 middle values and add them and divide by 2. Yeah, like that sounds correct. But in like in code, like in places I've seen, or like code I've read, like this is the formula we use. And if you use this formula, like first last divided by 2 or first plus last minus first divided by 2, you would only get one position, not both positions, right? So like the middle of this array, using either this formula or this formula will give you 3, and not 3 plus 4 divided by 2. Right? So, I could leave this up to you to actually find out why we do it like this, and maybe you come and tell everyone in the Slack group, because I think that's an important point, right? Like in regular math, if you want to find mid and there are 4 points, you add the middle to get the middle there. But that's not how it works in at least coding problems. But I don't know why. So, I would like to ask you to find out why and let us know. But
okay, but if it's still do this last minus first divided by 2, right? That's 5 minus 2 divided by
no, not 5,
2, right?
not 5. So the first and last that we're doing here are not the numbers, they're the indexes. So 0, 1, 2, 3. So this is mid of an array.
Okay.
So it's not the values we care about here. This formula assumes that the array is sorted, right? Like, so we sort the array, like we need to make sure the array is sorted, and then we use this formula to find the middle of the array. So these are the formulas used to find the middle of the array, right? So if we do first plus last, this would be like 0 plus, 3 minus 0, something like this, divided by 2, right? 3 minus 0 divided by 2 is something like 1 point something, right? This comes to 1. So it's like 0 plus 1. And that gives me 1. And the array at 1 is what? Is 3, right? So that would be the mid.
Okay, then I guess then this one will be like double backslash.
Sorry?
Like instead of one backslash, it should be like, because you're getting like the like this division now means that this 3 divided by 2 be 1.5. But like
Okay, is that like a JavaScript
if
thing?
you,
No, it's a
no,
Python thing.
Okay, that's fine. I mean, in
It's
Java,
like
if you do
integer division.
if I do int mid like this, once I know the variable is an int, it automatically drops all the decimals. So if in Python you need to add 2 slashes, that's fine. That's what I'm saying, like just semantics. Because Python doesn't have, you don't specify, you can just like create a variable anyhow you want. You just come and create a variable and go on. But in Java, you need to add the type. Once you add the type as int, Java would automatically drop the decimals. But yeah. So yeah, like that's how you find the mid of an array. But I want you to actually find out like the stuff you were asking, because I don't know the answer, but I think it's really useful for people to know. All right, cool. So I'm going to try that for a second. Again, I'm going to copy out like another a way to read the inputs from somewhere. I don't have to spend time on that. So what we're doing here is we're reading all the distances of people. So we know that each distance has only 2 values, right? So I create a multi-dimensional array that has 2 values for each array within the bigger array. The bigger array would be the size would be n, which would be the total number of people that want to come for Adora's thing. And so we now read all the distances and put them into the multi-dimensional array, and then pass that into a method. All right, cool. So our method is called minimize total Manhattan distance, right? And for this, we want to return distance. So that'll be something like pirate static int this. We have a multi-dimensional array, right? And I'll call it distances. Cool. So we can break this into like a couple of sections, right? So the first thing we need to do is find sorry, one sec. We want to find the meeting points. Yeah, so find meeting points. And then when we find meeting points, we want to find total distances, something like that, yeah? Because what we want to return here is return the minimized total distance, right? So we want to find meeting point and find total distance is total distance, yeah. And so we can just have a method here. Let's just say we have a method that returns the meeting points. We will call this meeting points return, call a method that does find meeting points, passing distances. This is an abstraction for now. We don't really care right now what it's doing. But then after we get the meeting points, we now know that we need to find the total distance that everyone has traveled to that meeting point, right? So we just do total distance is equal to 0. Then we go over like each distance. And add it to the, like find the distance to the meeting point and add it to the total distance. Okay, so what is the formula again? So the formula is something like formula is to get the distance of each person to the meeting points, we would do something like x minus x meeting. So the x of the current pressing minus the x of the meeting point, absolute value of that, plus the y minus y meeting, kind of the same thing, right? So what we'll be doing here is absolute x. So this is like absolute x, right? So the x of the pressing right now is, give me one sec. So distance is current pressing and x, because the distance is like this, x is going to be the first value, right? Like 3, 4. So we know x will be at index 0. And we want to subtract that from the distance of the meeting point, right? So meeting point x, which would be 0 as well. Then absolute y would be something like mass the absolute I'm doing the same thing but for y, right? So 1, 1, this. Then at each point, I want to increase total distance by the sum of x of absolute x and y, right? So absolute x and y is the distance that this person has traveled to the meeting point. So the person at I, the distance they've traveled is absolute x to absolute y, and I want to add their distance to the total distance we have. Then I will just return that distance, right? So this is pretty straightforward. If you have questions, please interrupt me. In the meantime, we want to find the meeting points using like the stuff I was saying. So we want to return this, call it find meeting point. We know we're getting like an multidimensional array of distances. Okay. All right. So what do we do here? We need to get all the x's and all the y's and sort them, right? So one thing we can do is to create an array of x's. So someone is still asking about Java. Yes, we're using Java for this session. But again, I ask, why is the language important? Like, what is the issue? Like, let me know if there's something about Java that's confusing you. But again, I'm saying that the language doesn't matter too much. Java is just like what I'm most comfortable with for these things. So yeah, I want to create an array for x and y's, because at the end of the day, we need to sort x and y's, right? So remember, we'll fill x and y somehow. Just give me a sec. Fill x and fill the x's array and fill the y's array. But before we fill them, remember that what we want to do is we want to do like a sort on them to make sure that they're sorted. Like remember, like you know why I was sorting, right? Because we need to sort to be able to find the mid. And so when we sort both x and both y, we now find the mid of x. So something like mid x is equal to, remember that we had 2 ways to find middle. Copying this out, pasting this in here. I can try the first one, the second one, since that is a bit simpler. But actually, I'll use the first one. So first is 0 plus 0 plus last index is what? So x is the length minus 1 minus 0. So there are 2 brackets here. There's 1 bracket here, there's a division, there's division. Okay, I don't know if this makes sense, but please, I'm removing this one so it doesn't confuse anyone. but first is 0. Last index. So this is first index. This is last index. First index. Maybe that's clear. Last index is the length of x length of the x's array minus 1, and first index is 0 again. Then we divide it by 2. So this way we get mid of x, and we just do the same thing for mid y as well. So we do y's length minus 1, blah, blah, blah. All right, and then at this point, we have mid of x and y. So all we just do is return this as the meeting point. All right, so mid x and mid y. So this will return an array that contains the distance, the meeting point location. All right, so how do we fill x's and fill y's, right? So, I mean, that's pretty straightforward. Like we go through the distances and just get it from there, right? So that's pretty straightforward. I divided by distances, the length, I plus first, x's I would be whatever this distance, the personal distance is 0, and y's I would be distances on 1. Okay, so this makes sense. Like, please interrupt me if what I'm saying doesn't make sense to you. I will try to explain again. This makes sense so far. So here we have the distances. I create an array for x's and y's. To get x's for each distance, I get the value at the first position. For y's, I get the value at the second position. When I'm done getting x's and y's, I sort them so they're sorted. Then I find the middle of x's and middle of y, and I just return that as the meeting point. And when I get the meeting point, then I just calculate the distance that everyone is taking to reach that meeting point, and I add it to the total distance, and I'm returning that. Does that make sense? Okay, so I'm not getting any feedback, so I'm going to guess it is. It makes sense. Expected output is 2, the output is 8. All right, cool. Why is that happening? Ouch. What is the example? 1, 2. All right, so let's debug this for a sec. Let me find out why that's happening. So we know distances is this. Okay. I find meeting points. I want to print out meeting points. Let's see what's here. Let's send the out the print line. How do you print again? How do you print arrays? There's a way to print arrays in Java. Arrays to string or something. Meeting point. Okay, so I want to first see what the meeting point is. Ouch. That might be the. All right, so meeting point is 0, 0. Interesting. So there's something happening here. Oh, interesting. So mid x, this is the middle of an array. Hello. Okay, I'm missing this. So when I do like all of these, first index plus last index minus first index divided by 2, all of that gives me an index. But I need to call the value, like to get the actual mid of the array, I need to return not the index, but the value at the index, right? So that is what was missing here. So for x's, I just get the point at that mid index. For y's, I get the point at the mid index. Let's see if that helps. Right, so my mid is 1, 2 now. That looks more like what I want. So I will comment this out, but I think the printout is affecting the output. Right. Cool. Yeah, returning the middle index rather than the right. Yeah, thank you, Eunice. That is exactly it. So does anyone have any questions at this point? I'm going to try and submit this. Let's see. I think we have to end here. There's one more question. There's always one more question with these things somehow. So I think maybe next one we'll probably start the last question. Maybe. So yeah, this one. This one is interesting. I think people should solve it. It is an interesting problem. But I don't think we'll have time today because I need to go. So yeah, maybe another time. But if anyone tries to solve it, they can mention me on the Slack channel and I will try to reply and help if you have any questions. So in the absence of any questions, I'm going to end it here.
Is this section recorded?
Adara says it's on YouTube, so I think so.
Okay.
All right, cool. Yes, please ask a question. Ayomide, you can ask your question. Hello. Okay. You can ask on the group. I'm not sure if you actually want to speak here. So Adara, I think we're ending here. I don't know if you're on the call. The constraints on each task. So let me quickly answer. Yeah, I want to quickly answer something, sorry. So someone's asking how do we interpret constraints, right? So constraints, so for example, in this question, n is at least 1. So we know that n cannot be 0. So when you're thinking about your edge cases and all of the extra checks you need to have, it's important to check your constraints because if n can be 0, then you probably need to cater for that. But you know that n is would be at least 1 and would go up to something like 100,000, right? So sometimes the size of the input also influences the kind of solution you have, right? So if that your input is something like 1 million or 1 billion or something, like you're getting 1 billion values in an array, I don't know if that's possible, depending on what the size is. Like a quadratic solution or a solution that is worse than quadratic would probably not be what you want because it would be really slow for an input size of 1 million, right? Because that would mean quadratic means 1 million times 1 million would be your time complexity, which is bad for a size of 1 million. So sometimes like your input, the constraints are useful to help you think about edge cases and also to help you think about the type of solution you should have, right? All right, cool. So yeah, I'm done here. Bye.
Thank you very much.
Thank you very much.